Okay, so this problem which we are going to solve, if you notice its denominators, they are x plus y, x minus y and x minus y only. So we are going to assume in the same way that what we are going to assume is, let 1 upon x plus y, that will be our m, and 1 upon x minus y, that we are going to assume to be n. Okay, so one, we have this. So therefore our equations, how exactly they are going to turn up, let us try to see the same. Therefore our original equation will become 10m plus 2n is equal to 4, and the second equation, it will be 15m minus 5n is equal to minus 2. These two equations we have got so far. Now we are going to solve these two equations simultaneously. Okay, so for that matter, again I am going to use that method itself. Therefore while calculating capital D, coefficients we are going to utilize, therefore there will be 10 to 15 minus 5. 10 to 15 and minus 5. In this method, while solving the determinant, we are going to have multiplication, that means 10 multiplied by minus 5 followed by minus 2 multiplied by 15. So thereafter, while solving the determinant, we are going to have 10 into minus 5, that should be minus 15, and minus 15 into 2, that should be 30, and therefore minus minus, that should be minus 80. That is the value for D we have received. Similarly, we are going to calculate dx and dy as well. Therefore dx is going to give us, well, dx is no more over here, therefore we are going to call it as not dx, it is going to be dm. Therefore in place of dm we are going to write 4 2 and minus 2 minus 5. Therefore 4 2 minus 2 minus 5, therefore equal to, multiplied by 4 into minus 5 minus 2 into minus 2. These two things we have, we are going to solve it. Therefore 4 into minus 5, that should be minus 20, and minus 2 into minus 2, that should be plus 4. Therefore we are going to have this final answer to be minus 16. So dx's value we have received so far. After getting the value for dx, we are going to calculate dn. So while getting dn, the determinant should look somewhat like this. Determinant should be 10 4 and minus 2 minus 5, 15 minus 2, I'm sorry, 15 and minus 2. Cramer's rule we are using in here. Therefore 10 multiplied by minus 2 minus 4 multiplied by 15, therefore equal to 10 into minus 2, that should be minus 20 minus 60, therefore it should be minus 80. So D, dm and dn, these three determinants we have solved so far. Based on them we are going to calculate m and n's value over here. Therefore formula for m is going to be dm divided by d. Okay, and for n as well we are going to have a similar formula, dn divided by d. So dm's value, what we have received earlier, was actually minus 16 divided by d. So d's value was minus 80. After simplification we are going to have it to be 1 upon 5, and dn's value was minus 80 divided by minus 80, so that should be 1. So m and n, these two value we have calculated so far, but actually we were not after m and n's value. We were supposed to calculate x and y's value, so we are going to go after that. After substituting these original values of n and n, we are going to have 1 upon m's value was actually 1 upon x plus y, so therefore it should be m's value. If we substitute in here, it should be 1 upon 5, taking invertendo, we are going to have x plus y is equal to 5. Let us call this as our equation number 1. Same methodology we are going to apply for n as well. So while solving for n, m's value was actually n was equal to x minus y, and we have got it to be 1 in here. Therefore again taking invertendo, we are going to have x minus y is equal to 1, and this will become our second equation. So these two equations we have, x plus y and x minus 1. Now using these two equations, we are going to calculate value for x and y. Now exactly by how to solve or how to calculate this x and y's value, how to solve these two equations together, we are supposed to calculate the same. But see, we are having an option in here. What exactly that option is? That is actually we can actually calculate by using a Cramer's rule, or it can be calculated by our original old method as well, in which we used to make the coefficients same. These both the options we are having. So far while solving the equations, I have utilized Cramer's rule. See, it is completely up to us. I am going to utilize over here our old approach, the very first approach we had used. Therefore what I am going to do, I am going to add these two equations together. Therefore adding equation 1 and 2, x plus y was equal to 5, whereas x minus y is equal to 1. Okay, we are adding these two equations. So therefore x plus x, that should be 2x, y and y they will get cancelled, therefore equal to 0, equal to 6. We are after x's value, therefore x is equal to 3. That is the first value we have received so far, first important value we have received so far. Now we are going to calculate this y's value as well by using this x's value. Therefore we are going to substitute this value of x in equation number 1. Putting x is equal to 3 in equation 1. Therefore what we are going to have, the original equation I am writing, x plus 5 was equal to 5. Therefore 3 plus y is equal to 5. Therefore y is equal to 5 minus 3, and y's value we are getting it to be 2. So therefore finally what we can write is that x and y's, these two values we have calculated so far, they are actually 3, 2 is the solution of given simultaneous equations. That's it.